what we're looking at today is 3.6, interpreting functions. So, solving systems by substitution. In prior work, the meaning of f of x equals g of x has been discussed. So we know that's when our equations are intersecting. It's that intersection point. So this means to find the point where the two equations are equal and where the two graphs intersect. It's possible to find the point of intersection algebraically instead of graphing the two lines. Since f of x equals g of x, it's possible to set each equation equal to the other and solve for x. So here's an example that they go through. You've got f of x equals 3x plus 4, g of x equals 4x plus 1. They set them equal to each other. So now we have 3x plus 4 equals 4x plus 1. We want to solve for x. So they subtracted 3x from both sides. They also subtracted 1 to move the constants to one side, the variables to the other. So we subtracted the 3x because it was positive, and we want to get a 0x. Some of you guys are having issues with this. So use this example to really help you. When we do this movement to get from one side to the other, it needs to be the opposite sign, because if it's not, we would end up, if we added 3x here, we'd end up with 6x. That's not going to help us at all in trying to solve this. So you want to do opposite signs. So we subtract 3x. 4x minus 3x is 1x. Then we subtract the 1. 4 minus 1 is 3. So we end up with 3 equals x. Then we take that value and we plug it back into either one of the two equations to find out what the y value is. So it's 13. So I'm going to do number 3 with you guys because it has a fraction, and I'm sure that probably is freaking you out when you see that. So let me get this set up. So just like in the example, we're going to set these equal to each other. So we're going to have negative 2/3 x plus 5 equals negative x plus 7. Now I'm going to add my 1x. So if it helps to include the 1 there, by all means do that. So anytime you just have an x by itself, there's always a 1 in front of it. I think that'll help some of you guys in thinking through. So negative 1x plus 1x is just 0. So this equals 7. Then negative 2/3 plus 1. So 1 is the same thing as 3/3. So negative 2/3 plus 1, or plus 3/3, is going to give us a positive 1/3 x plus 5. Now we need to get the 5 over with the 7. So we subtract 5. We have 1/3 x equals 7 minus 5 is 2. Now, to get rid of the 1/3, we need to take and either divide or multiply by the reciprocal. So I'm going to multiply by 3 over 1. So x equals 2 times 3 is 6. So the x value of our ordered pair is 6. Well, we still need to figure out what the y value is. So I'm going to plug the 6 back in. Now, I could plug it into the f of x 1, but my guess is most of you wouldn't do that because it has the fraction and you don't like working with fractions. So instead, you could plug it into the g of x. You will get the same answer either way, so it doesn't matter which way you choose to do it. No matter what, you will have the exact same answer. So with this one, we're going to have negative 6 plus 7. So negative 6 plus 7 is positive 1. So our point of intersection is the ordered pair 6, 1. And yes, you need to write it as an ordered pair. Don't just show me that y equals and x equals. I want to see the ordered pair. And remember, x always comes first in an ordered pair, y comes second. So ordered pair is x, y, always, okay? So that's what you guys are doing for 1, 2, and 4. You are taking and setting these two equations equal to each other and then solving for x and then plugging it back in for y. All right, the next thing that we're looking at here, describing attributes of a function based on a graphical representation. So use the graph of each function provided to find the indicated values. So we've got all these different graphs and different indicated values. So we're going to look at 8. For this, we have d of -5. So this is very similar to what we looked at just last time in taking and finding these values. So when our number is inside the parentheses, that means we look for the x value. So here we go to the -5 on the x-axis, and we look to see what the y value is. Well, it's 1. For b, d of 4, you're going to go over to 4 on the x-axis, and then you're going to find where it is on the y. So it's at 2. For d of x equals 4, so this is where we look at the y-axis and figure out where the function exists at this y value. So at 4, it doesn't exist off to the left, it's over to the right, it's right here, and that is at x equals 3. Now, this last one, d of x equals 0, so we look at the x-axis, because that's when y equals 0, or when our f of x function equals 0. And notice we have 1, 2, 3, 4 different places where this function exists at d of x equals 0. So we have -6, we have 0, we have 1, and we have 5. So those are all the possible x values we have for when d of x equals 0. So you guys are going to do the same thing on 5, 6, and 7. The first two, you look at the x-axis and find the y value. For C and D, you look at the y-axis and find the x value, okay? All right. The next section. For each situation, create a function or use the given function to find and interpret solutions. Fran collected data on the number of feet she could walk each second and wrote the following rule to model her walking rate. D of t equals 4t. What is Fran looking for if she writes d of 12? So what does it mean if she's saying d of 12 equals something? What's she looking for? Well, she's looking for the number of feet she can walk in 12 seconds. Because the t is the time and the 12 is in place of the time, so that means it's in terms of 12 seconds because we were talking about seconds. In this situation, what does the d of t equals 100 tell you? It tells us she walked 100 feet, and it would be asking us how much time did it take? All right, for C, how can the function rule be used to indicate a time of 16 seconds was walked? So, just like A, d of our time of 16 equals blank. That shows us 16 seconds, and we want to know how much time has passed, or how much she's walked. For D, how can the function rule be used to indicate a distance of 200 feet was walked? Well, this one's just like B. So d of t equals 200. So understanding what these functions are and what they represent, how to interpret them. So being able to interpret a function is very crucial, especially when we're dealing with real world situations. And even when we're not, when we're just dealing with purely mathematical situations, understanding what the different ways to write these functions, what the different function notations mean, how to interpret that, that's crucial to being able to understand and comprehend and solve. All right, so for your keyword for this lesson is interpret. Interpret is your keyword for this lesson. All right. The next part, we are looking at describing features of functions from the graphical representations. For each graph given, provide a description of the function. Be sure to consider the following, such as increasing, decreasing, min, max, domain, range, etc. So we're going to take and look at these. So we have decreasing, increasing, we increase some more, we decrease again. So we definitely have a lot of increasing and decreasing. It is continuous because it's constantly going. until it ends, but it's continuous over the interval there. Our domain is going to be the furthest to the left that we go is 0. The furthest to the right that we go is 10, 11, 12, 13. Our range, so it's the lowest we are, is at 1. The highest we go is up here, which is 11. That's our range. Increasing, so here's the first place where we start increasing. So we're at 1, 2, 3. So increasing, that's an arrow pointing up if you can't tell, is from 3 to, well, it increases all the way up to here within the parabola, but then it continues increasing all the way over here to 10. So from 3 to 10, it's decreasing from 0 to 3 and from 10 to 13. Where's our maximum? Maximum is 11 at x equals 10. Our minimum is, well, use your range. Your range is always going to tell you your maximum and minimums, by the way. This will be your minimum. This will be your maximum. So minimum is 1 at, well, it's when x is 3. We don't have any x-intercept, so no x-intercept. Y-intercept is at 0, 10. So these are some of the things that you can take and find. I definitely want to see you showing the domain and range, increasing, decreasing, minimum and maximums. Those are some pretty important things to be able to determine and find within a graph. So make sure you're finding all of those. All right, your keyword for this lesson is interpret. Interpret. If you guys have any questions, feel free to ask. Have a great day.